All right, so in B, if you answered purple, then you understood the thing about gene expression. So you were right. In B, then the kernel would be purple. And that's because you have the recipe to make something that prevents the white or the purple color from showing. That's how the white is white. But that recipe doesn't get made because the thing that triggers the making of that is not near it. So if you mess with the gene or the regulatory sequence of the gene, so that's the DNA sequence that is upstream of the gene that says when, where, and how much the gene will be transcribed, then you don't see or at all or not as intense of an effect of the transcription of this gene. So in this case, yes, the kernel. So far we have the white kernel, we have the purple kernel, except that in corn, we know that there is an activator. And so these were just the scenarios of if there is no activator. But we're going to see, this is leading to, well, the part C. I hate how I'm like trying to anticipate the excitement and I almost ruined my question. All right, so here in corn, you have the activator and you have the dissociator. And there you have the allele for white kernel. Now, remember the activator is the element that picks up this guy, and then it gets dropped off and inserted somewhere, and it could be here, breaking into pieces, or it could insert itself inside of the gene. And now, if this is a recipe on how to make white kernels, then you broke that recipe. But it can also jump out of it. And I don't know how Barbara McClintock came up with the idea of DNA jumps around. It needs two parts of DNA, one that tells the other one when to jump around. Sometimes it breaks a gene, and sometimes it will jump out of the gene. So let's see in C, what would be the color of that kernel?